Welcome, everyone. Think of me as your personal guide today as we navigate this step-by-step explainer. We're going to break down the fundamental concepts of Chapter 2, Matter, together. If you're a beginner wanting to grasp exactly what the universe is made of, well, you're in exactly the right place. We're going to take all that textbook knowledge and transform it into a really fun, easy-to-understand journey. So let's dive right in by thinking about a super basic household chore. Have you ever boiled water on a stove and really watched what happens? You start with a pot of liquid, apply some heat, and suddenly bubbles form and the water just turns into invisible gas or steam. This perfectly demonstrates matter changing states right before our eyes. You see, science isn't just trapped in a lab somewhere. It's literally happening constantly in your own kitchen. Here is our quick game plan to categorize the universe around us today. We'll cover 1. Meet the matter around you. 2. The 4 states of matter. 3. Sorting substances and mixtures. 4. The magic of allotropes. 5. Solutions, colloids, and suspensions. And finally, 6. Chapter summary notes. Let's kick things off with Section 1. Meet the matter around you. Now, the absolute crucial point to understand here is that matter is defined as anything that has mass and occupies space. So what does that mean? It means the air you're breathing, the water you're drinking, the rocks outside, and yes, even you. We are all examples of matter. At its core, matter is built from tiny little blocks called atoms, and the incredible diversity of stuff we see every day is just different combinations of those atoms. And this brings us to a really vital distinction in chemistry, how matter actually changes. Remember that boiling water from earlier? That was a physical change. We altered its temperature, sure, but it was still H2O at the end of the day. The chemical composition stayed exactly the same. But if we were to take 2 totally different elements and chemically combine them to create something brand new, that's a chemical change. It alters the fundamental chemical properties to form a completely new substance. Moving right along to Section 2, the 4 states of matter. It is truly fascinating to zoom in and uncover the microscopic secret behind these states. The state of any given matter is entirely determined by how its particles are arranged and how they move around. Picture a solid. The particles are tightly packed together in a really neat grid. In a liquid, they're a bit looser, sliding past each other. In a gas, they're spread way far apart, bouncing everywhere. And then there's plasma, where the matter is so intensely energized that electrons are actually stripped away, creating this electrically charged gas. It all comes down to the arrangement and energy of the particles. We can actually categorize these macroscopic properties really neatly into a table for your notes comparing gases, liquids, and solids. Notice how gases have low density and are very compressible. Why? Because of all those large empty spaces between particles we just talked about. Solids, on the flip side, have high density and are not compressible because their particles are already packed so tightly together. And liquids? They sit right in that sweet spot in the middle, highly dense but still totally able to flow. All right, on to Section 3, sorting substances and mixtures. Think about making your morning tea. You grab some milk, hot water, tea leaves, maybe a little sugar, and you stir it all together. What you're doing is physically combining different ingredients without causing a chemical reaction. You're creating a mixture. Mixtures are simply physical combinations of substances that don't contain the same types of particles, but they still retain their own chemical identities. The sugar is still sugar, and the water is still water. I really want you to use this step-by-step story as a mental checklist every time you encounter a new object, kind of interrogating it to find out exactly where it belongs in the chemistry world. First, ask yourself, is the matter chemically pure? If the answer is yes, then boom, it's a pure substance, like an element or compound. If no, it's a mixture. Then ask your second question, is this mixture uniform throughout? If it's completely blended like salt water, it's homogeneous. If you can still see the different parts, like in a salad, it's heterogeneous. If we map out this exact sorting story visually, it creates a fantastic flowchart. You have matter at the very top, branching down into pure substances on one side, which include your elements and compounds, and mixtures on the other. And then those mixtures split again into homogeneous and heterogeneous. It is such a brilliant visual map to just lock into your memory. Which brings us to Section 4, the magic of allotropes. Okay, this is where things get genuinely magical. It's fascinating that the exact same type of atom can just be arranged a little differently to give an object completely new structural forms. We call this allotropy. It's defined as the property of an element to exist in different physical forms within the exact same physical state. So, same atoms, but an entirely different physical reality. Let's look at the absolute best example of this. Carbon is absolutely the master of allotropy. Carbon atoms can arrange themselves into a super rigid 3D network to become diamond, literally the hardest substance we know of. But if you take those exact same carbon atoms and arrange them in flat 2D layers instead, you get graphite. That's the soft, slippery stuff inside your pencil, and it even conducts electricity. Or they can form a sphere of 60 atoms called a buckyball, which looks exactly like a tiny hollow football. 3 completely wildly different materials, all based purely on how those carbon atoms decide to bond. No way, right?
Let's dive into Section 5, Solutions, Colloids, and Suspensions.
Let's look at some basic chemistry math for homogeneous mixtures. The substance that is actually getting dissolved, like salt, is called the solute. The dissolving medium, doing all the hard work, like water, is the solvent. And together, when the solute particles become microscopic and perfectly uniform, they make a solution. So, solute plus solvent equals solution. It's that simple. Now, you might be thinking a solution has to be a liquid dissolving a solid, right? Actually, scratch that. Solutions can be in any state. The air you're breathing right now is a gaseous solution. Nitrogen is the solvent dissolving oxygen and other trace gases. That carbonated soda you love, that's a liquid solution where water is the solvent dissolving carbon dioxide gas. Even solid metals can be solutions. Alloys like brass and bronze are created by uniformly mixing different solid metals together. But hey, what happens when things don't dissolve perfectly? Well, if the particles are between 1 and 1,000 nanometers in diameter, so they're large enough to scatter light but still small enough that they don't separate out and settle at the bottom, that is a colloid. But if we're dealing with a heterogeneous mixture where large solid particles are just spread out throughout a liquid without dissolving at all, like a glass of muddy water, that is called a suspension. Finally, let's wrap this all up with Section 6, Chapter Summary Notes. I highly recommend pausing the explainer right here and grabbing a screenshot of this cheat sheet. These key takeaways form the absolute backbone of everything we've covered. Just remember, matter has mass and takes up space. Its state completely relies on how its particles arrange themselves into solids, liquids, gases, or plasma. Pure substances are your elements and chemical compounds, while mixtures are just physical combinations, and those solutions, just homogeneous mixtures made of a solute and a solvent. You know, science isn't just a bunch of facts trapped in a textbook. It's everywhere around you, making up the fabric of your daily life. So I want to leave you with a quick challenge. Look around your room right this second. Based on what we just learned together, how many different states of matter, mixtures, and pure substances can you identify right where you're sitting? It's like a giant puzzle. Test out those new sorting skills today. Thanks so much for joining me on this explainer, and keep questioning the world around you.